to space the triangles on the wall surface of the window. So in order to do that, we have to get the sides of the window. And we can get these sides using the getSides message, which will give us a sides output from here with the sides of the window. So, okay, so let's trigger this message. For example, every 2 seconds automatically. So we will continuously have the sides of the window. So if we modify our window, every 2 seconds it will give us the sizes of the window. Okay. So now we want the ratio. So we actually want to divide the x from by the y. So we can simply do something like that. It will automatically divide the first input for the second. And this is the ratio of our window. So we can use this value as the ratio of our window, and we can use this value inside this jit.gen. So let's go inside, create a new parameter, and let's multiply this x, the x, for the ratio. That's everything it gets to have the window, the triangle spaced on all the windows. So let's create a message ratio, receive ratio 3, and then we have to bang here, and the triangles will be spaced on all the window space, but actually they still go beyond the vertical edges of our window. So in order to prevent that, let's multiply actually the output for a number smaller than 1, so they will get this position will get a bit smaller. Let's try. Yeah, that looks good. That looks good. Okay. Actually, we need a way to also bang this jit noise every time we change the dimensions of our window. For the moment, let's just bang it every time we go full screen. So every time we go full screen, our jit word sends out a message called init, which is basically a bang. Is a bang preceded by the message init. So every time we go full screen, we will receive a bang, and we can send this bang first, for example, to the getSides message, and then to the jit noise. So let's actually trigger this bang 2 times, and let's first send it to init1, which will be our getSides message, and then to init2, because we want them to be triggered in this order. So let's actually delete these. Let's only get the sides when we go full screen. This will be init1, and this will be init2. So let's try. If we go full screen, you can see that actually the triangles have been spaced on the right way. So they are spaced on all the window. Okay, good. Now let's go on with the second part of this tutorial. So basically what we need to do now is to rotate those triangles according to the mouse position so that they always point toward the mouse. Cool. So to do that, we will need our mouse coordinates from the screen to world. So let's create a sender, mouse cards. Here, let's call them mouse world cards, mouse world, basically. And let's create a receiver here, mouse world. Let's create a message. So mouse world $1, $2, 0. So we set the data to 0. Connect to the jit.gen. Let's create a parameter inside this jit.gen called mouse world 0, 0, 0, because it's a 3-component parameter that comes inside. And then we can use these mouse coordinates to rotate these triangles. Now, what it takes to rotate a triangle in a two-dimensional coordinate space. It needs a rotational matrix. A rotation matrix. So if we go into Wikipedia and we look for rotation matrix, we see that we get the formula for this matrix that will give us a rotation on a two-dimensional space. So if we multiply this matrix for this vector x epsilon, we get something out of this matrix that is also a two-dimensional vector, which will basically be coseno of the angle. Let me say coseno di A multiplied by x plus minus sign of A multiplied by epsilon. And then this will be our x, our new x. And then our epsilon will be basically sinus sine of A multiplied by x plus the cosine of A multiplied by epsilon. Okay, so this is what we need to achieve in order to rotate a point in a two-dimensional space. Okay, so let's create this matrix 2 vector multiplication. Since we don't have matrices in Gen, we can just explicitly write these multiplications. So let's do something like this. We will need to multiply the cosine. Let me take this image. We need to multiply the cosine of our rotation angle for x. And so we will need to do something like that. This will, inside here will come our angle, and inside here will come our x from here. Okay, so then we need to multiply sum that for minus sign of the angle multiplied by epsilon. So actually instead of summing, since it's a plus minus something, we can actually just subtract that, and this will be our new x. Okay. And then we need our epsilon, that will be basically the sine of the angle. So we already have it actually, multiplied by x in this case, plus the cosine, of the angle multiplied by epsilon. So the cosine of the angle actually we already have here, multiplied by epsilon. And this will sum together, this will be our new epsilon. Okay, let's actually, let's create a parameter for our angle just to test it. Let's say, for example, 180, boom, boom, and then they turn of, let's actually create a message from outside, we call it angle, and let's try to input some numbers. Whoa, actually it's in radians, as you can see, so it doesn't really make sense to multiply by 180 because this is in radians. So if we multiply, if we use an angle of pi, we will get a rotation of 180 degrees. So super. If we rotate 2 pi, we will get 360 degrees rotation. So kind of cool. But we actually, instead of using an arbitrary angle, we want to use the angle between our mouse position and every one of these particles. Now to get this angle, we can use the atan2 function that I was talking before about. The at_an function, as I said briefly before, gives us the angle between a point and the x-axis. And so this point could actually be the position vector resulting from the subtraction of our world coordinates, sorry, not here, the subtraction of our world coordinates with the position of our particle. Whoop. And then it works like that. We have to switch the x, to switch the y, and the y of this vector goes inside the first input of the at_an, and the x goes in the second input. And this will give us the angle between, basically between our mouse and a particle. Okay, so if we use this angle inside this calculation, whoa, we see that something weird is happening. So why are they rotating in this weird way? Because these triangles are not rotating around their center. That's the thing, the triangles are not rotating around their center. In order to rotate them around the center, we need to first calculate what is the center of this triangle, subtract the center to the position of our triangle, and then sum back this center again after we do the rotation. So you will maybe think, okay, the center of our triangle is actually our input 1. This is actually not true, because this is not exactly the center of our triangle. This is just the point to which we started constructing our triangle. It's not really the center. So to find the center, we actually had to sum together all these three vertices. And then we need to divide them by 3. And then we need to subtract this vector before going inside the rotation. So we subtract it, boom. And then we need to sum again the center to our output here. And now they are rotating around the center, these guys. And now they are pointing toward the mouse. Every one of these triangles is pointing toward the mouse. Now, let's say we want to change the size of our triangles and maybe make the point a bit more pointing. So this vertex we want to make to extrude it a bit more. When we can actually just divide this by the sides by 2 on the y for these two vertices here. Ooh. So this and that. The y of our two vertices there. And then maybe make the size a bit bigger. So, sorry, I did something wrong. It was actually not this one, but this one. Exactly. So, this is now our triangles are a bit more pointy. Let's make them a bit bigger. Okay, cool. That's extremely cool, in my opinion. If we want more triangles, it's easy. We just have to make this matrix bigger. For example, let's say we want 600 of them, and then we have to make this 3 times minus 1. So 3 times will be 1800. 3 times minus 1 will be 1799. So, boom. We have now our triangles pointing toward the mouse. Okay, so boom, this is it. Thank you guys for watching. If you want to download the patch that I showed in the beginning of this tutorial, is inside my Patreon. So you just to become a patron of mine and you can download it. And by the way, I have also a website in which I share a lot more tutorials and a lot of patches also for free. I write the link in the description, so check it out. Check it out, this sounds really cool. I usually don't use expression like check it out, but somehow it sounds kind of cool. And yeah, I think that's it. See you on the next tutorial. Ciao, ciao.